Looks like that. All right, so this one is the greatest integer, and it asked me to identify the parent. So the parent is just the greatest integer of x. And then it asked me for transformations from the parent function, right? So the transformations from the parent function, I swear I just saw my Python. Did I? I think I did too. I've got three things going on here. The slides are the easiest, right? That's right 5 down 1. But that 2 on the bottom can be kind of confusing, right? Because it's inside the operation, it's inside the greatest integer, it's applying to the x, and x is being divided by the 2. It would be the same thing as writing 1/2 times, right? So I would say that this was a horizontal stretch of 2. Because you got to flip it. Horizontal stretch of 2. Because this could be written this way, and it would be the same thing. And since it's inside here, if it were outside here, that would be vertical. But because it's inside this operation here, that makes it horizontal. Everything horizontal is opposite. So because it's less than 1, it's a stretch. Because it's horizontal. You're talking about on the reciprocal one? The reciprocal one's a little different than all the others. It does, yeah. Yeah. Of 2. You have to flip it so it's of 2. Was there not, or was there? Was it due today? Did it say due today? No, you gotta turn in. Yeah. Use your computer and take a picture of it. All right, what else in your homework? 15. 15 says, I've got this function, 2x minus 5 squared plus 3, reflected across the y, then translate. So I take this and I'm doing these transformations. So the first thing I do is I reflect over x, which means nope, it says reflect over y. So reflect over y will put me a negative here in front of the x. And then it says translate it right 6. So if I'm going right 6, I subtract 6 here. And then it says down 2, so I'm going to go down 2 from here. So my new equation is going to be negative x minus 11 squared plus 1. What else? Number 3, I'm assuming we flipped over. Okay. Number 3 says to identify the parent and any transformations that are happening. And so the parent here is obviously that reciprocal, and this is the one where things get a little sticky, right? If it's in the top, it's vertical. If it's in the bottom, it's horizontal. Okay? Because my x is in the bottom. So if it's this function, stop, Logan. If you have a number in top, that's vertical. If you have a number in bottom, it's with the x, and that's horizontal. Okay. So for this one, it's in the top, which means I'm going to call it vertical. So I'm going to say that this is a vertical stretch of 6. And then, of course, the down. Yes.
Okay, so it's like that.
This only applies to this function.
talking about the number or
The number. If there's a number in top, it's a vertical stretch or shrink. If there's a number in bottom, it's a horizontal stretch or shrink. Right. I don't know that. What else? 6 and 16. I'll do 6 first, then I'll flip over to 16. 6, the parent function here, here's what you have to realize with these, is you have to understand how you could rewrite them, right? I could rewrite this as negative 1/2 times the square root of x, and it's the same thing. So my parent is square root of x. What have I done? I've got to reflect over x. That's my negative in front. And then this is vertical because it sits out front. So vertical is what it is. So it's a vertical shrink of that. The bottom and the top only applies if it's that, I didn't even know where it went now. If it's the reciprocal. Yes. Numbers on top or bottom, whenever I told you, that's only if the parent is 1 over x. If the parent is 1 over x, then if you have a number in top, that's vertical. If you have a number in bottom, that's horizontal, but that's only with that function. This is square root function. It's not a reciprocal function. All right, and then 16. F of x, negative 3 over 2, x plus 4 to the third minus 2. And it says this function, things have already been done. So what's already been done to it, I have to undo, right? So it says that it was stretched vertically by 3. So if it was stretched vertically by 3, what did I do? How do you stretch? You multiplied by 3, right? So to undo that, undo would be to divide by 3. So where am I dividing by 3? I'm dividing this one by 3. Okay? Then it says it was, where am I? It was translated down 5. So to undo that, I'm going to move it up 5. That's on the end here. Okay? And then it says that it was moved 7 left. So to undo that, this left 7 adds 7. So to undo that, I'm going to subtract 7 from my x. So where do I end up? Will I end up at negative 1/2 x minus 3 cubed plus 3? That's what I had negative 3 up there. I know. I have that. I was like, I think that's undo. All right, let's switch gears. You ready, Freddie? I'm ready to move past these. Today is everybody's favorite. Are we getting back to the equation?
what are y'all doing?
What's piecewise?
Piecewise. Huh?
Piecewise.
Oh my God, if it was the less than greater than thing? Oh my
No,
God,
I don't like that because I don't know
test.
what that is.
I don't understand. Is this actually everyone's favorite or are we just sarcastic?
Listen, Sometimes we do things and we do them because they're standard and they don't really come up a whole lot more. Sometimes we do things that show up all the time. Yeah, piecewise, we do piecewise in calculus all the time. Logan, be so for real. With continuity and everything else. How would I tell if this function was continuous with calculus?
With calculus? Graph them all.
No. What's the definition? Bro, we are done with that. How did you prove
MPT.
You're lying, right?
Yeah. You have to
The
make sure the
limit?
limit from the left and the limit from the right are the same and the function value is the same. Oh my gosh, like, what do you do?
Don't be glad you got that right.
I hate that class.
No, you don't. Shut up. Stop saying that. People are starting to believe you.
I'm just kidding.
Then I'm not going to have anybody. All right. Let's start easy. Write this first one.
Easy. I'm gonna hold your hand. You do not know. Will we need our calculator?
No. Maybe later, not right now.
That was a dead one.
Understand what this is saying. What this is saying is, go away, I'm teaching.
I'm sorry.
When x is smaller than -3, this is my equation. When x is between -3 and 7, this is my equation. And when x is bigger than 7, this is my equation. Okay? All right, let's see if I can help you make it make sense. If I asked you to find like a function value, like let's say I asked you, what is f of -5? The first thing I'm going to have to do is decide which equation I'm going to use because there are 3 different equations here, yes? So I have to decide, is -5 smaller than -3, between -3 and 7, or bigger than 7? Smaller than -3, right? -5 is smaller than -3. So it fits this scenario. No, because you got to do absolute value first. All right, so look, your first step is determine which equation. Then all you have to do is plug in. This is whenever I'm evaluating a piecewise, okay? Now, so f of -5, I've already decided that it's the first equation, and we all understand why I chose the first equation, right? I chose the first equation because -5 is smaller than -3. All right, so I'm going to plug -5 in for the x. So I get 2 times the absolute value of -5 minus 5. I use this equation, and instead of x, I put -5. Smaller than 8. You decide, yep. Nope, I only asked you what's f of -5. All right, watch. So what is -5 minus 5? -10. Absolute values work like grouping symbols in that you do them first. What is the absolute value of -10? 10. What is 2 times 10? 20. What is f of -5? 20. That's easy. This is an example. What is f of negative 5? It's not, green is the only problem. Yes. Guys. Stay with me. What if I asked you to find f of 2? Do it. Don't blurt it out. See if you can figure out f of 2. Don't say the answer. No, I just said don't say the answer. Shut up. Okay. All right, which equation did you choose?
Middle.
The middle. Why did you choose the middle? Because 2 falls between -3 and 7, yes? So this, I'm going to use this equation and I'm going to plug 2 in. So I've got negative 2 squared plus 4 times 2, which is -4 plus 8, which is 4. All right, listen. Listen, guys. How do I know which equation I used? I used the one that has this stipulation on it because 2 falls in between here. So I take this equation and I replace the x's with a 2. If I told you, all right, look, if I told you the f of x was -x squared plus 4x, and then I said, what is f of 2? What would you do? If you had nothing but just that, what would you do? Shh. Luke, come sit down. What are you doing? And that's exactly what I did. I plugged it in for x. Look what I did. How did I know that that was my equation? Because it has to do with this number right here, that x. Is that x smaller than -3? Is it between -3 and 7? Or is it bigger than 7? You choose the last one. So I've got square root of 2 times 7 plus 6, which is the square root of 20. But you split it, right?
I remember this stuff, bro.
Wait, what?
Yeah.
Wait, no, what did you take out though?
Why'd you take it?
Square root of 4 is 2. All right, let's do another. Guys, I need y'all to be quiet. This is just evaluating. We haven't even graphed yet. All right, I've got a function altogether. Altogether, I have 3 different functions, 3 different pieces of functions that are making up one big function. I don't know what's happening at the breaks. They could be jump discontinuities or they could be continuous functions. I don't know yet because I haven't graphed it. All I've got is the equation. So right now what I want to do is algebraically evaluate what the values are, okay? All right, so I'm going to give you 3 problems, and I'm going to give you just a minute to do them. The first one, I'm going to ask you to find g of -3, and then I'm going to ask you to find g of -8, and then I'm going to ask you to find g of 3.1. And I'm going to give you, that's your greatest integer. You always round down, though. Always round down. -8. So look at your number line. Where's -8? That's okay. All right. -3, where does that fall? That falls between -4 and -2, so this would just equal 8. Nothing else, just 8. No. No, because there's no x on it. If there was an x on it, yes, but there's no x on it. It just says that no matter what you plug in between -4 and 2, you get 8 back out. All right, now -8 is using this first equation, right? Because -8 is smaller than -4. So I get 1/2 -8 to the third plus 7. Harris, help me out. What was -8 to the third? 512? -512. And then half of that would be 256. So -256 plus 7. What's wrong? Yes. Because Harris told me. Yeah.
What? No, never mind. She just got stuck on this side.
Oh.
No, but she immediately 1/2. Yeah, I didn't do that.
Because in order of operations, exponents come before multiplication. All right, 3.1. 3.1 is going in this last equation. You probably figured as much since these went in order each time. 3.1 minus 4, which is -0.9. Remember, I'm rounding down. If you have to envision a number line, put a number line on there. Here's -1. Here is 1. I'm always rounding down to the nearest integer. So if I'm at -0.9 and I round down, that puts me at -1. Yes? Yep. Down, always down though. All right, let's do a graph. Ready, Freddie? We did this in Algebra 2. Huh? I'm fixing to show you how to do it. You don't have one yet. These would be non-calculator on these. No, you could use your calculator. Huh? Yeah. Okay, here we go. Oh. This is different than evaluating. All right. Now, understand what piecewise does, right? Piecewise takes literal pieces of different equations. So if I had x plus 3 minus 1, that's an absolute value, right? But it cuts off wherever 0 cuts it off, and it erases half of it and leaves the other half. And then this one's a line, and it's going to cut off, and it's going to erase part and leave the other part. So I've got to kind of think think about that before I graph it. Now, here's what I do whenever I graph these. I want to, before I start, identify any important parts like vertices. And we'll do several examples and I'll tell you what I'm talking about. That says etc., by the way. In other words, for this absolute value, right, if you think about that parent graph, the parent graph, and you just took a test on this, so I hope you all remember, the parent graph of absolute value starts at 0, 0 and does this, right? This one has been slid which way? Left 3, down 1, right? So this vertex or this starting point occurs where? -3, -1, right? If I go left 3 and down 1, this is at -3, -1, and then I have my absolute value, right? The parent graph slid left 3 and down 1. So, no, that's what I'm saying, because before you start, you need to think about any important parts of that graph, the vertex of an absolute value, for instance. So I know that the vertex of this graph is at -3, -1. Is that in my interval? It says this is the graph when x is smaller than 0. Yes, it is, right? Okay. So here's what I'm going to do. Remember what I need to graph an absolute value, right? I need the vertex, I need a point on one side, and then I need to reflect it over just like a quadratic. Okay? All right, here's what I'm going to do. I am going to look at my cutoffs. I'll call them. Find those points. Harris. Who are you sticking that finger up at? Stop touching. What do I mean at the cutoffs? I mean at the place where they're disconnected. So at 0, if x is 0 in this one, and I know it can't actually be 0 because there's not a line under it, but if I were to plug in 0, what would I get? Negative, what? 2. Right? I want to plug in my cutoff point because what I'm going to do, listen guys, if it's less than or it's greater than, I'm going to plot it, but I'm going to plot it with an open dot. Okay? Because it can't actually be that, right? All right, so let me just start. This is going to start, I hope some of it starts coming back to you because we did do this, at 0, 2. Now I said another important point was what? The vertex, -3, -1. That's my cutoff here. I plug in my cutoff part. You plug it in 0 plus 3 minus 1. Yep. Well, if that's where you're cut off here, in this case, you start at whatever that number is. That's right. Start at whatever that number is. Listen, because this is not easy. This is not easy because we've thrown in some other equations in here. Okay, stay with me. Everything else is closed. It's just that one point where you cut it off. Okay. Now, Because an absolute value is symmetrical, I don't have to actually calculate another point. I can say this is my axis of symmetry. I can go over 1, 2, 3, 1, 2, 3, and I can graph from here. Okay. So every point on that graph is closed except for the one point where it's cut off. That's the only one that's, all right, listen guys, listen, this is not easy and I need you with me. Okay, the only point that is possibly open is the point where it's cut off, okay? This graph, and I'm coming right back there, the absolute value of x plus 3 minus 1 looks like this. -3, -1 here, and it does this, okay? But my graph is telling me cut it off at 0. At 0, cut it off right here, erase this part, and keep this part. So I put an open dot here because that's where I cut it off, because it can't actually be 0. So I put it's actually less than 0. So that's why I only have this part, and it doesn't keep going forever this way. It stops. It'd be filled in, it'd be closed in. And we're going to do that in just a second. Yes. All right. I needed to find the cutoff point. That's my cutoff point. That's where I stop the graph. I plugged it in. I always look at the cutoff by plugging in. Depends on what that is. Guys, I am struggling to talk over you. All right, if I was at this one, my cutoff is -4, I'd be plugging in -4. I'd be plugging in -2. Whatever the cutoff is, that's what I'm plugging in. Here it's 0, and that's why I'm plugging in 0.
Would all of them be, why did we go, okay, so we went the 3, we went over 6?
I counted over, here's my axis of symmetry. That's my, I counted over 1, 2, 3, so then I went 1, 2, 3.
Okay.
Because it's symmetric. Folded over there. All right, listen. All right, now look at your second equation, and we're going to follow the same process. Now, lucky for us, a line doesn't really have any other important points I need to look at, okay? I don't have a vertex there to make sure that it's included or not included. So for this one, I just need the point, the cutoff point. What is the cutoff point? 0, plug it in, you get -5. 0, -5 is my cutoff for that one. Okay, so 0, plug it in. Yep. And this one's filled in. So 0, -5 is my cutoff point for that one. Filled in because closed because it's got a line under it. Okay? Plugging it into this equation. So 2 times 0 minus 5. Okay?
What does that have to do with it?
Okay.
What's the cutoff? What?
How the absolute value thing, this arrow is like this. Because I'm plugging at 0, and we got 2, so we cut it off here.
Right.
And then what's the 0 -5?
We're going to cut it off right there.
So it's another cutoff.
This is another thing.
We're graphing 2 different pieces of 2 different graphs.
So they're 2 separate.
Yes.
Yeah.
Oh, see, I thought it was the same one.
Yes. No, it's 2 different. Okay. Now look, because this is a line, I only need 2 points to graph a line. I'm going to pick an x that's bigger than 0, so I make sure I'm on the right side of 0. 1. If I plug in 1, I get 2 times 1 minus 5, which is -3. So 1, 1, 2, 3. Because 1 is bigger than 0. It tells me be bigger than 0.
So you can choose any number?
Any number bigger than 0. I would too. You could do rise over run. If you did up to over 1, you could do that as well if you understand. Yep. Okay, keep it close. Now, I'm not done. Is this function continuous?
No.
It's a jump.
It's a jump.
It's a jump. It's a jump.
It's a jump.
Doesn't matter. Okay, first of all, can you draw it without picking up your pencil? No, so it's not continuous. Is it a hole? No. Is it a vertical asymptote? No. It literally, you go boop, boop. Oh, I got it. Jump down to this one. It's a jump discontinuity. It is a jump at 0. Okay? What you got, Will? Because of this line under that inequality sign. All right, still not done. Plug in what? Pick an x that's bigger than 0. Look at what the cutoff is saying. Are you talking about which one are you doing? That's just a line. 2x minus 5 is just a line. Yep. All right, listen. What is the domain of this function? Okay, domain's easy, right? Negative infinity to infinity. Now be careful before you answer this. What is the range of the function? Oh. -5. Include or exclude? Include it because it's filled in right here, right? -5 up to infinity. Because it's filled in right there. That white point is filled in. It includes 5. So I have to include 5 here.
Wait, so if it was open, it'd be negative?
Oh, it'd be a parenthesis. I'm sorry. I was sorry.
It'd still be -5, right?
Yes. No, if it was up, what?
If it was open, there would still be
Oh,
-5.
yes, yes. Just this unit. Each unit I change them. We're going to do one more easy one and then I'm going to make it harder. Well, so far, the ones we've done are all functions that you did in Algebra 2. I'm fixing to throw a new function in there for you. Not yet. Graph it. Tell me if it's continuous or not. If it's discontinuous, tell me the type and where it occurs. And give me the domain and range. And I'm going to give you I'm not doing that. All right. The first is a line. No important points on a line, right? Say right, because there's not. I mean, every point is important, but nothing that I need to really look out for. So I'm going to plug in my cutoff point first. So I'm going to take this and I'm going to plug it in. And if I plug that in, I get -3, -1. Right? Okay. Is that open or is that closed? Closed. Now, you can plug in another Lane's sheeted slope, and you could do slope as well from here. It doesn't matter. Just make sure you go to the left and not to the right. But if I pick an x that's less than -3, so maybe -4, and you plug that in, what do you get? 0. That's the direction that it's going in. There's that piece of that line. Remember, it's piecewise. I have pieces of graphs, yes? Yeah. Okay. Now, I want us to think about this parabola for just a second. This is a quadratic. What transformations have been done to this quadratic? It's flipped over the x-axis. It's a vertical shrink. So the vertex has not moved, right? Where is the vertex of this graph? 0, 0. Is 0, 0, right? Because that's where the parent graph starts. The parent does this. If all you do is flip it over and stretch it or shrink it, then the vertex doesn't move. The only way the vertex is going to move is if you add or subtract something. So is 0, 0 within my domain of numbers here? Yes, it's right here, right? So I need to make sure that I include that. And now let's plug in my cutoff point. That's not the only point that's possibly open is the cutoff point. Everything else is closed. This is not my cutoff. I was just saying that whatever else happens, this is my vertex. And I wanted to check to see, is it in my range of numbers? Watch and I'll show you. I hope this will make a little more sense. That's not your first point. Just wait just a second. That's my vertex. But hold on. Hold your thought for just a second on the vertex. You don't even have to plot it now if you don't want. Okay. I'm going to plug this in. When I plug that in, I get negative 1/2 times negative 3 squared, which is negative 4.5. That point then is negative 3, negative 4.5, right? Is it open or closed? Okay. 1, 2, 3, 1, 2, 3, 4, and down a little bit more, 4.5. There's no line under it, so it's open. Okay. Now, I know that my vertex is still at 0, 0, right? Because it's a parent graph and it's been stretched or shrunk, but it hasn't been shifted any. So this is one side of a parabola. I need the rest of it, right? Because it says everything on this side. So all I'm going to do is take this point and reflect it. That's right. So 1, 2, 3, 1, 2, 3. Everything is closed except the only one that's possibly open is the one where they meet, where they cut off. I did. Why did I plug what in? Oh, I plugged in the first, and then I found the vertex, and I reflected. Okay, so the vertex is the same as the parent because the only thing I did was shrunk it and flipped it. I didn't slide it anywhere.
Because we was doing absolute value. What? I don't know why.
Everything on it is closed. The only point that's possibly open is going to be this point where they're cut off, where you plug in what it gives you. That's the only point that might be open. Other than that, everything is closed always. Yeah. That I just know that that's my vertex because I know what a quadratic parent graph looks like. And for a quadratic parent, if I just have x squared, it's on 0, 0, and it opens up. So what did I do to get from here to here? I flipped it. Well, that's easy. And then I did a vertical shrink. So I made it wider. But making it wider does not change where the vertex actually is. If you go back to algebra 2, the vertex of a parabola of a quadratic in standard form is opposite b over 2a, and b is 0. So you could do it that way if you'd rather. The first one's a line, not a vertex. I mean, not a quadratic. All right, look. Yes. Is it continuous, yes or no? No. It's what type of discontinuity? Jump at -3. What is the domain? What's the range? That's right.
Oh, okay. Oh.
Because it says x is always bigger than -3, so it keeps going to the right forever.
What's range left to right?
Bottom to top.
So it's negative thing because the two exits, the volume total.
You got what I'm putting.
Yes. All right, I'm going to do one more with you, but I'm going to go ahead and give your homework to you if you got it, if you understand. I'm going to do a pre-cal one with you.
So like the bottom, like how we always have to know what that is.
You would.
So the bottom one will always go on. That's always in the second.
Yes.
We'll always have to know what that is.
Because you'll have to know from the parent graph to the transformations.
So we're always going to plug it and then to the first one for the bottom.
Mm-hmm.
And then whatever this looks like,
You got to figure out what it looks like and do it. Yeah.
It might even be wrong equation.
It could. It could. It's not. They're going to be. They're going right now. They're going to be one of those. How many was it? 7 or 8 parent functions that you have.
So you're going to do what we did for homework.
Yes. Right. That's not true. That's not true. All right, let me show you. No. All of them. I might cut them down. Just wait.
What are you doing? About 8, 6.
All right. You're going to do 1 through 4. Those will take long. And then we'll do number. Wait, what was 1 through 4 first? All right, but listen, I don't want to. I would do this one with you, but I want to have one that you practice with too. But I want to show you how we go about because this is a pre-cal problem because I got this reciprocal function in here. This one was an algebra 2 problem. This one is a pre-cal problem. You see the difference? Yeah. This is a reciprocal function. Okay, so here's what I want you to think about before you even, and we're going to do a whole unit on reciprocal functions soon, or rational functions, graphing them. But here's what I want you to think about. If I'm talking about the parent, okay, the parent has asymptotes here, here, and here. Yes? And then it does something like this. Agree or disagree? That's the parent. Now, what transformations have been done to this one? I shifted left 3, vertical stretch of 4. Okay, so what does that look like on a graph? Well, if I shift it left 3, 1, 2, 3, that means here's my asymptote, but this is still an asymptote. Okay? And then the stretch is just going to have to do with where the points are. I'm not so worried about that, but I want you to see that. My question is, if I cut it off at 1, because it says cut it off at 1. Positive 1. Where is positive 1? Right here. So I'm taking this pink graph and I'm cutting it off right here. So notice what's included on this side. All of this asymptote, right? I need to make sure I have that in there. So you have to understand these transformations as you go to know if it sits within this range of numbers. Does that make sense? Do you see what I'm saying? The asymptote moves. Yes, the only thing that's going to move the asymptote, the vertical asymptote, is if you shift left or right. The only thing that's going to move it up or down is if you add or subtract a number on the end, a vertical shift. So vertical shifts are going to shift your asymptote. Horizontal shifts are going to shift your vertical asymptote. Remember, because there's two. There's this asymptote and this asymptote. Okay? This one has only moved this asymptote. 3 left. Yeah. You do. So you're really trying to visualize what does this look like if I don't cut anything off, just in general, what does this look like? Well, this would look like an asymptote at -3, an asymptote at 0, and it would do something like this. It always has one at 0. This is that parent graph. All parent reciprocals, because this is 1 over x. That's that parent graph. So the 4 is just a vertical stretch. It's just going to stretch it out. It's going to make it kind of do this a little bit more and stretch a little bit. I'm not so worried about that right now because I can find those points. But what I do want to worry about is, remember I said, look to see if the important parts are in your range of numbers. Is my asymptote within this x is less than 1? And the answer is yes. Sometimes it'll be no, yeah. Sometimes it'll be no, and you wouldn't have to worry about it. You need to see where is it cutting my graph off. Yeah. Yes. Now, I'll tell you, I'm going to go a little bit easier on y'all for these reciprocal functions. For these, find your cutoff point and find your asymptotes, but you can just sketch the rest of it. You don't have to find any exact points on those. So if I'm graphing this one, if I plug in 1, I get 4 over 4, which is 1, right? For this one, if I'm graphing this, I would just go to 1, 1. Is it open or closed? Close. I'm going to put my asymptotes. And I'm going to just come in and do this and this. And I'm okay with y'all doing that right now. Because we're going to talk about some more precise ways to graph them. But for right now, if you just make sure you pick this point up and you pick up that asymptote, I'm okay with that. Then come into this one. My cutoff is 1. So when you plug it in, what do you get? -5. Open or closed? And slope of 2. For this one, yes, but for reciprocals, no. Reciprocals, no. No, you could. You just don't have to. Now, this one, continuous, not continuous. Not continuous. What's the type of discontinuity? Jump and infinite. I've got an infinite at -3. I've got a jump at 1. Yeah. I did the slope as 2. I did rise over run. I went up 2 over 1. Because it's a line. 2x minus 7 is a line. So I just did, this is 2x minus 7. So I started here and I just went rise over run. 2 over 1. Because this is like mx plus b. Pick a point. Pick a point. Pick a point bigger than 1. Like, pick 2. And if you plug in 2, you get negative 3. Yeah. What's the domain? Nope. I gotta leave that negative 3 out. There's an asymptote. Negative infinity to negative 3. Negative 3 to infinity. Because every 1 over x has asymptotes at 0 and 0. And I split it to the left 3. Because it said plus 3, and that's a shift left. Because it can't be negative 3, there's an asymptote.